All right, welcome everybody. There's actually more people here today than I was expecting. I got a handful of emails from a few people who said they couldn't make it because of the cold and poor weather conditions, but thank you for being here on a ugly day. I wasn't sure how many people would be here. Let's begin with these announcements. So you've just submitted homework number 3. So then the next one that's up is homework 4. That's due a week from today. I think that many of you are seeing that the scores are posted on MU Online, and that the grader also gives you some feedback, some text feedback that you can look at. I just wanted to let you know that if the grader makes mistakes and has accidentally taken off points for a problem that you actually did correctly, please let me know, because I want you to get all of the points that are entitled to you. I want you to get everything that you've earned. That said, sometimes students will argue over a half-point deduction for this and that, and that can get a little tiresome if it happens all the time. But like if it's a genuine mistake and you deserve extra points, then I'd like to hear about it so I can fix it. The quizzes I've graded and the scores are posted on MU Online. I meant to bring those down to hand out, and I might pop up to my office while you're working on the in-class exercise so I can return those to you. Any questions on the announcements before we start talking about the interest factors that's taken from Chapter 2? All right, so we've done a lot of foundational work for the in-class exercise and the topics that we're going to address today. I think you're going to find the transition into this new chapter really smooth, and I'll again make a plug for just spending a little bit of time after each lecture reviewing the applicable textbook section. I think it's a great book, and I think it's worthy of your effort to read through it. Okay, there's a table I'd like to give you of equations. Let me hand that out now. And these equations will allow you to calculate a ratio for any type of cash flow problem you're likely to see in this course. Now there are, as I mentioned before, there's pre-solved tables in the back of your textbook that solves these for different n values and different interest rates. But occasionally you'll have a problem where maybe it's an odd interest rate, 11.5%, and you got some extras? All right. How many do we need? 3 over here. So sometimes you'll have an odd interest rate that there's not a table for, and you have to use the equation. Sometimes it'll be for a number of years that doesn't appear on the table. So you kind of need both. The other thing is that these interest factor formulas allow you to be more precise than the tables are. And I'll show you what I mean by that, but you can just carry it through to more decimal places when you're actually solving the formula yourself. Now remember, in the past, we've talked about the language of what's in these parentheses. What it says there in the column that's labeled symbol, that's kind of a language, and it's a sentence. And what that sentence means for the top one, for instance. So F/P means find F given P. So you're finding a future amount based on some known present value. I is going to be the compounding interest rate, and N is the number of periods into the future that it's compounding. And so the formula for that probably looks pretty familiar by now. Now the next row down, P/F, is find P, so find the present, that's the unknown, given some amount F in the future that is known. And then the I represents a discount rate because we're moving it from the future towards the present. So anytime it's moving back in time, we call that a discount rate rather than a compounding interest rate. And so each one of these, each row, you could turn what's in the brackets into a sentence that explains what kind of a problem it is. And this table here where it says converts to F given P is kind of a reminder of that same language interpretation that we've discussed before. Some of these formulas get pretty hairy. If you look at this P/G, we will go through and calculate that just once for kicks, so we can say that we did. But there are automated ways to solve all of these, where you're not always having to use the formula, or you're not having to look up in the table. Eventually, I'll show you some tricks in Excel that will make calculations a lot faster. But, of course, you don't get to use Excel on the FE exam, so you have to know how to do this all by hand. I'm just curious, how many of you have heard about the FE exam before? Okay, almost everybody here has heard about the FE exam. I go down to Clemson, South Carolina about 4 times a year to help write the FE exam. I write the environmental questions on the FE exam, and it's really opened my eyes to, number one, how fast you have to work through those problems on the test. On average, you've only got 3 minutes to solve each of the problems. But then the good news is that because you're supposed to be able to do it so quickly, they really are bite-sized, quick little problems. So a lot of what we do this semester, I'm trying to train you to work quickly through these engineering economy problems. And if any of you end up taking me for fluid mechanics, I try and have the same emphasis where, you know, we'll go deep into the details and the theory, but then I also want you to be really fast at the application because it's good for the FE exam, but then it's also good when you're just out in the field and need to make a real quick analysis. All right, so these interest factors are one of the ways that we're going to be accounting for the time value of money. This is a scan of one of the factor tables from the back of your book. So the appendix in the back of your book is just page after page of tables that look like this. And you can see up in the corner, this says 8%. I think your textbook has 1/4%, 0.5%, 3/4, 1, 2, 3, 4, 5, 6. Then they maybe jump to 8. And then the rows, it has n down through 50, and then I think it jumps maybe 50, 60, 70, and then, you know, it starts making bigger jumps down through the number of years. So it's the same kind of notation as far as what's in the numerator and what's in the denominator. So this column here where it says compound amount, for this column you'd use the factors that are provided to find a future value given a present value. So one known present amount, you use one of these factors to find an unknown future amount. What's it called when we move money forward in time? Compounding. That means it's getting bigger. So what we would expect, if the amount is getting bigger in the future, you'd expect this ratio to be greater than 1. And it is. And so what's that saying is that the ratio of the future amount to the present amount is, let's see, for 1 year, 1.08. And that makes sense. If it's 8% interest, then that future amount is going to be 1.08 times as big as the present amount. Or if we compound it 5 years, the future amount is, you know what, I've got the cursor right on top of it. So for 5 years, if you're compounding a certain amount 5 years into the future at 8% annual interest, then the future amount is 1.4693 times as large as the present value. So if we know the present value, we just multiply this factor by the actual numeric amount for P, and that gives us F. So that's compounding. Discounting, remember, is what we do when we move money from the future backwards in time. And so we would expect that these ratios would be less than 1 when we're discounting, because remember, P/F says find an unknown present amount given some known future value. So if we have, let's say now that this is 8% monthly interest, because remember, a period doesn't have to be a year. A period could be a quarter, it could be a month, it can be any duration of time. So if 8 is 8% per period, let's say that it's 6 periods in the future. Some known present payment is 6 periods in the future. To find the present value of that future amount, you'd multiply 0.6302 by the known future amount, and that would give you the present value. So these tables are pretty useful. Any questions so far? let's apply it with just a couple of on-screen examples before I give you this handout of the in-class exercise I'd like you to work through. Okay, so a person deposits $5,000 into an account that pays interest at a rate of 8% per year. The amount in the account after 10 years is, just to get us thinking about the FE exam. The FE exam, most of the questions are multiple choice, although not all. About 80% are multiple choice. So it's obviously, if we're moving this into the future, the way we would summarize the problem is we would say this is find the future value given some known present amount. I equals 8%, N equals 10. So that's the language that we use to summarize the problem. And if we want to draw a cash flow diagram to illustrate it, it would look like this. 10 years, P is 5,000. We're finding F in the future. So let's do this the table lookup way. There's the equation way and the table lookup way. So let's go to the table that was on the previous slide, and let's find N equals 10. Okay, so N equals 10 is this row. And then the column that we need is we need the F/P column. So this first one, 2.1589. So the future amount is going to be 2.1589 times the present amount. So here in the solution you can see we have 5,000 times what's in the brackets there. And we could substitute the number 2.1589 for what's in the brackets because, remember, we think of what's in the brackets as a ratio. It's the ratio of future to present. So if we multiply that ratio by the present, then it gives us the future. It's just kind of an algebraic manipulation there. And so that amount is 10,795 after 10 years. Okay? Let's look at another one. Small company wants to make a single deposit now, so it'll have enough to purchase a backhoe costing $50,000 in 5 years. If the account earns 10% interest per year, the amount deposited now is nearest to... All right. First things first, I think it's always a great idea to prepare a cash flow diagram. Even if the problem doesn't say that you absolutely have to, it's a great idea. It's just accident avoidance. You know, you avoid mistakes when you take your time and you're thorough. So if we graph this, we've got a withdrawal we're going to take in 5 years. So that's an arrow up in a known amount of F. The P is a downward arrow because we have to make the deposit today to make sure that money's in the bank and available to withdraw. Okay, so this is 10%. We don't have the 10% table to refer to. I just showed you only the 8% table. But what we can do is find a 10% table someplace. If you look up in the 10% table in your book, what you'd see is that for P/F, I equals 10%, N equals 5, then the factor is 0.6209. And that means it's $31,050 that we need to deposit at the present. Okay, so we're going to practice that. I've got 3 problems for you to solve. Let me bring them up here on the screen, and I'll also hand them out. For the first problem, I don't specifically say for you to draw a cash flow diagram, but I'd like you to. And so I put that there on the screen with the stars here. Draw the cash flow diagram. It's not on the paper I'm giving you. And while you're figuring this one out, let me step up to my office and grab your quizzes so that I can return those. Let me put up the solution to the first problem on the front side of the paper just to see how things are going. So I asked you to do a cash flow diagram. And so for this one, we are receiving $50,000 in the future, so we need to give that label F, and it's in 7 years. So that means the end of period assumption means that unless it explicitly says it's at the beginning of the period, we always assume it's the end of the period. And so here's our first year from 0 to 1. And if anything happens in the first year, we do it at the end of the period. So if it's after 7 years, that means it's at the end of the period. So that's why I put it on the number 7. And P equals unknown with a question mark and a dashed line. It's also up because we're trying to find out the present value of the payment. And if this payment is going to be a revenue in 7 years, then its present value to us now is positive. So it's an upward arrow. So there's the cash flow diagram. Okay, part A, summarize the problem in the form of what we put in those parentheses there. So this is how we would summarize this problem type. P/F, I equals 8%, N equals 7. Now I got a good question as I was circulating around. Somebody asked, do you have to write I and N? And I think it's a good idea to do that because it could otherwise be kind of easy to forget like what's supposed to be in the second position, what's supposed to be in the third position. So just so that there's no ambiguity from who's looking at your calculations or when you're doing them, I think it's useful to label I equals 8 and then even to put the percent sign there. Because it's conceivable that you could say I equals 0.08. So writing the number as a decimal rather than as a percentage. So just so there's nothing is left up to uncertainty or interpretation. We just write all of the information that's required. Okay, part B. Choosing from the list of equations that I gave you, that handout with all the formulas, write the formula that should be used to calculate your own factor. And so what's the equation? So the equation is P divided by F is 1 plus I to the minus N power. So then we substitute in part C, and let me show you something here. I'll zoom in on it. This dot, dot, dot that I'm showing here, what that means is it's just a way of me indicating that there's a lot more decimals, and I kept them in my calculator when I did the calculations, but I don't want to write all 16 of them or whatever that my calculator is displaying. So that just means that a series of numbers continues. And it's an acknowledgement that there's a lot of precision there that I'm retaining in the rest of the calculations. I didn't round off. I mean, maybe you'd be tempted to say 0.58. But we don't want to round off prematurely because then our answer isn't accurate to the nearest penny. And if we can, we'd like our calculations to be accurate to the nearest penny. So try and employ that same notation of dot, dot, dot when there's additional digits that you're going to hold on to. And so I did the same thing in part D. In part D where it's asking, so what's the actual amount? What is P? So P is F times that factor. So 50,000 times 0.58349, etc. gives us 29,174.52. So that is accurate to the nearest penny because I did it the equation method way. But if you notice, when we did it by the table lookup, that factor that's on the table is only 4 digits long, 0.5835. So the implication of that, we can only report our final answer to 4 digits of precision. So I have to say 29,180 rather than trying to claim some number of pennies, because from this factor that only is 4 digits long, I only have 4 digits of precision in my final answer. And so 29,180 is the correct answer when we round off with the given factor value. So the two important lessons, I mean, aside from just how to do problems like this, the two important lessons are, this is a language, and, graphite for your mechanical pencil is cheap. Go ahead and write a few extra steps. Be expansive in your language. show a few extra steps, give all of the details so that there's never any ambiguity of what your method was. And that'll be to your benefit on exams. Like if you make a mistake in your calculations, but you show that your steps are correct and your thinking was accurate, I don't care so much if you just type something wrong in your calculator. I mean, I'll give you maybe 80% of the available points if your answer's wrong, but if you still showed that you had all of the steps in the correct order. And so if you document your thinking and you show your solution strategy, it's going to help you out a lot on those exams. So the language, be expansive, and then precision and round off issues is what I want you to take away from this first example. Any questions on this first one? All right, let's take a look at problem number 2. Okay, I got another good question as I was walking around. Someone asked, how do you express that something was looked up from a table? And so you could just write that in words, from table A5 or whatever the appendix number is. Or the other way is like this, is we summarize the problem inside the parentheses. So this problem is P/A, I equals 8%, N equals 3. And then if you say equals and some number, that's implying that you got that number from a factor lookup table. Because I never show what's the equation for that problem type. So this is a way of communicating that that number comes from a lookup table. And again, you can see that the answer has been rounded off to as many digits as we have in the factor. This factor had 5, rather than the last one only had 4. So this factor, 2.5771, that's 5 numbers. So 1, 2, 3, 4, 5, 32,214. So I wouldn't say 213 and 85 cents or whatever the calculator is saying, because anytime you write those extra digits, it's like you're claiming that's the precision and accuracy of your calculations. But in this case, we don't have that degree of accuracy. We can only quote it to the nearest dollar because of the factor. All right. Let's take a look at this last one. So use the equation method. Just a few minutes ago I said that pencil lead is cheap. So show all your steps. Don't just write the formula and then write the number, because if you make a mistake, then I don't know why you made a mistake and I can't give you as much partial credit. But if you say, here's the summarization of the problem, find A given P for an interest rate of 11.5% per period, N equals 3 periods, is equal to, and so now I've said that that ratio is equal to this equation. And so remember, inside the brackets, it's ultimately a ratio, the ratio of the annual amount to the present amount. So that ratio is, here's the formula for it, and then I make the numeric substitutions, and then I even do an intermediate calculation, just kind of like when you're double and triple checking your calculations in a quiz or an exam. I think it's useful to have these intermediate steps just so that when you do it a second time, you can look in your calculator and see, yeah, it matches what I did the last time I checked. And so it's an easy way to verify your work. And so then I've got this factor that I've calculated, precision continues. And then this one can be expressed to the nearest penny. Did anybody get that same number for problem 3? I kind of threw this together at the last minute, this third problem, so I'm glad we got the same answer. Okay. So if you've finished and you don't have any questions, you're free to go a few minutes early. However, I'm going to stick around for the next little while and answer any questions that some of you might have. Before anybody goes, I just want to point out one last time that your next homework assignment, problem homework 4, that's on MU Online. You could get an early start. The majority of that assignment is contained within the ideas that you've learned today. So if you're the early bird, you can go get that worm. Stay warm, and I'll see you on Friday.